All right, let's talk a little more in depth about entry points and entry point addresses. So as I said, an entry point earlier it's the first instruction where the programs are executed, where the real code actually starts. In Windows, to start execution, the loader or the OS actually passes control to the entry point. So what happens in Windows is when you double click on a file, when you double click on an exe, what happens is the file actually loads up. It actually loads up and it looks at the header of that file. It says, okay, this is an actual executable. Do I see MZ up here? Yes. Is it a P file? Yes. Once that happens, it says, okay, good. I've kind of verified that this is a real file that I can load. Then what happens at that point is Windows will actually go ahead and shift over to the entry point. And once it shifts over to the entry point, that's when the file code actually starts taking over. That's when the developers actually make their magic work and the file or the application does whatever it's supposed to do. So in newer operating systems, that process is a little more complicated, and the reason it's more complicated is because in newer operating systems like Windows 10, Mac OS 11, and even iOS devices and newer Android devices, there's some more protections that go into place. More verifications. Sometimes there's signing of applications, signing of certificates, signing of APIs and other things that go into place. So as I said, that basic structure always stays the same. Just remember, in some newer operating systems, a little more things happen. And that's why, when I talk about like starting your own lab and analyzing malware, I always talk about maybe starting Windows 7 or earlier. I do like Windows XP because you get the most basic type of instructions out there. So even if you are running a new program, you don't have to deal with these extra complications. Once again, if you have those extra complications, it's not a problem. You just need to know how to get around them, how to view them. It's just a lot more information to process, to sort out in your head. But once you're used to it, it's not really that big of a deal. All right, so once again, an entry point is the point where we go from load time to run time. That's what is commonly said about entry points, is we go from load to run. And that's that point in time, that specific area in memory is called the entry point. Let's examine an entry point in C++. So C++ is a common compiler programming language. As you can see, there's a main function. Commonly in C++, there is a main function that's pretty much in every C++ program. The main function is also where the entry point starts at. So we don't see it in hex mode over here. We don't see it in our, assembly mode. I'm just showing you from a coding standpoint where the entry point would be. The entry point would be right at the main function. Now in C++, you also do have load functions out there. You may have libraries that you're loading. You may have encryption libraries. You may have other external libraries you're loading. Maybe you're loading environments, but when you start programming in C++, you usually do it under the main function. That's where the code starts. That's where the developer works his magic, and that is where the entry point is on most programs in C++. All right, let's talk about the Python entry point. And then most people actually, when they think about Python, they really don't think about entry points in Python, but Python does have an entry point, most Python, as well as other scripting languages, are usually processed top to bottom. So basically, whatever you see on the top of the screen is processed first, and then it goes below that, which means that you could have other things before your entry point. A lot of times in Python, you have these import commands that over here you see import sys. This is basically calling external libraries and putting them in your system. So what happens is when you run a Python program, and it is possible to run a Python program as an executable, there are programs that will turn Python scripts into executables. When you run a Python executable, what happens is these libraries load. You could have import commands, you could have multiple libraries that are loading, but once these libraries load, at that point, the entry point is actually the start of the source code. So the libraries reload, and then the entry point loads at the same time. Now, this is a little different than C++ because although you can have a main function in Python, normally you don't. And you don't always have to have a main function. With a Python program, even though you're importing a library, that's actually part of the code. That's actually a developer will actually say like, hey, this is the real part of the code. And with Python, not only are you loading the library, you're loading the library in runtime. That's the difference. So when you're loading the library, it's not just loading and then running. It is running while it's loading, or running as it loads at the same time. So what that means is that very first line, that import.sys, is actually the entry point at that point versus having to wait for the main function. So I want to talk about IDA Pro. IDA Pro is a common debugger. There is a public version of this debugger, but there's also a commercial version that you have to pay for a license. A lot of debuggers and compilers do have shortcuts that lets you jump to an entry point. So you can attach to a program on a debugger, and then you can jump to an entry point. IDA Pro is a very, very popular tool. And when you start doing malware analysis and even reverse malware engineering, you are going to have to get familiar with debuggers and compilers. IDA Pro is probably a tool you will be very, very familiar with. Now, there are other tools. There are other very popular tools besides IDA Pro. There's Binary Ninja is another tool that I use often. There are a few other tools as well. But IDA Pro is kind of known as the industry standard for debuggers, especially for malware analysis projects. One of the things, like I said, from all debuggers is you can jump to an entry point. So if you don't know where that entry point is, if you have a hard time finding that entry point, the debugger can find it for you and say, hey, this is the start of the program, and you can jump to that entry point. The IAT, or the import address table, basically is where the entry point exists. As I said, the compilers do already have shortcuts to jump to that entry point. Compilers such as debuggers, as we just spoke about, IDA Pro is a popular tool that will let you deconstruct that program and where you can jump to that entry point. But let's talk more specifically about what happens on the IAT. So there are statically and dynamically linked executables. What that means is that there are libraries within executables. Some libraries are statically linked. That means they're specifically in that executable pointing to other executables or other libraries. This is when you have DLLs. Sometimes when you open up a program and you see a whole bunch of DLLs, those are dynamically linked libraries, and you have statically linked libraries as well. So a DLL, dynamically linked libraries, run in real time, at runtime. A statically linked library runs in load time. Those are the differences. This all exists in our import address table. So when we look at the PE structure, we had our PE headers. We also have our import address table. So our libraries are loaded in the IAT. So in the C++, when we had our library that we were calling in, where that library is loaded at is it's in the PE portion of the file of the import address table structure. So the IIT stores and functions to be imported from DLLs. So the DLLs basically have the libraries in them, but the IAT table will actually go into the DLLs, figure out what it needs, and pull it from the DLLs and store it within the executable itself. So a lot of malware has capabilities in DLLs. So this is one of the most basic attacks that someone may do is they'll actually take a legitimate program that uses DLLs, and they know that a program is importing DLLs back into it. What they'll do is they'll replace one of the DLLs with malware. So it'll have a malicious library or malicious function in one of the DLLs. So basically they'll pull a malicious DLL. So the program itself is looking for certain DLLs. They know, hey, you know what, I'm going to replace this DLL with my own created DLL. I'm going to make sure it works. It has all the features that it needs to work, but it also has some malicious code or malicious behavior in that. That's what we call DLL replacement or DLL hijacking attacks sometimes. There's this term called packers. What a packer is well, it's not a football team like it is a football team, but it's also another thing. A packer is a compression tool. Basically, it's a compression program, and that compression program runs in runtime. So what happens is you have an executable, and you have that executable compressed. It's just like a zip file. Think about a zip file, but instead of unpacking a zip file, unzipping a zip file, and then having another program inside it, it's already the compressed file is already inside itself. So you just click on the compressed file just behind the background, and it's uncompressing and running. A lot of software developers will actually run packers because they don't want people to reverse engineer their programs. They want to copy protect their programs. Sometimes it's for security, but a lot of malware will actually use packers as well because they don't want their malware to be analyzed. So there's been a lot of tricks around packers. Most security researchers, reverse engineers will need to unpack a file a lot of times to truly look at that file. So a packer will remove the IAT, the import address table, when you do pack a file, when you do compress this file. The reason it removes that is because it doesn't want it to be examined, but that information is not gone, it's not lost, it actually gets rebuilt at runtime. So when you examine a file that's packed, it still looks like an exe. It has the exe function to it, it has the exe name to it. You open it up and something like PEView, a tool that we used earlier, you don't see anything in the IAT in the address table, but when you run the tool, it will be there. You still won't see it in the tool like PEView, but if you run it in the debugger while it's running, then you will see and be able to examine the address table. So let's look at a copy of the address table. This is another tool that I'm using. It's a screenshot of a tool called CFF Explorer. And you can see that it has a directory tree-like structure that you can access the IAT or the import address table. So let's look at some other PE file sections. You can see the PE files have multiple sections. Each of those sections have their own purposes out there. Each section has an optional name out there. They don't have to put a name out there. That's optional. And it also has permissions on each section. Sometimes the names can help us determine if the file was packed. So if we do open up the file and we see these names in CFF Explorer or another similar tool. By the way, I am using like different tools that do the same functionality. You've seen I've switched between tools. So that's just to show you the variety of tools that are out there. But when I do open it up in a different tool and I do see a name, it could give me a hint if the file was packed. So if I see something like UPX, it could mean, hey, a UPX packer was used. The reason this is important is because, like, if I want to unpack the file, I need to figure out how it was packed with. So if a file is packed with UPX, I need to get a UPX depacker. Basically, I need to like uncompress a file. Just like when you have a zip file, you know if the file is zip compressed, you need to have a zip program to unzip the file. Same thing with a packer. It is just a compression tool. All right, let's talk about the different PE file sections that are out there. We have our data sections. Our data sections include icons, images, string tables, and other types of metadata. We have our resource sections that includes things like timestamps, language code, and the binaries. Now, what that means is the resource section could have another binary in it. That means an executable that has another executable in it. That's kind of dangerous. Most of the time when we see an executable that has another executable in it, means it's malware. It's malware trying to hide within a legitimate program. So we have to be careful about that. Normally that's like a red alert. When I see that, a lot of security tools will actually see that. There's not too many legitimate reasons to have a binary within a binary. All right, I want to talk about another tool, PEView. Once again, guys, I am guys, girls, teams, people, everyone out there. I am actually showing you multiple tools that are doing the same thing because there's a lot of tools, and one of the reasons I'm showing you this is, first of all, there are tools that you are just gonna like better than other tools. Second of all, sometimes you get results with different tools. You get different results with different tools, and you have to look at multiple tools. Why do you get results with different tools? Well, it's because malware acts in different ways. They try and hide from the system. So I'm actually opening up this tool called PEView. What program am I opening up? I'm actually opening up notepad.exe. You can see that at the very top of the tool. Notepad.exe is being opened up. Actually, I want to go into the hex portion of this. I'm going to zoom in a little bit here, and you will see this MZ up here as the very first line. That's the value. We see the hex value as well on MZ, what it shows up as. What does the MZ mean? Well, it actually means that it is a PE file or a Windows executable file. Remember, that is the value we were looking at. We spoke about that earlier. I usually have this text, this ASCII, in almost every file. I think that's something that's just left over from legacy Windows, that this program cannot be run in DOS mode. That's in every modern program still. I think that's something just classically left over. PEView is like one of my favorite tools to use. It is a Windows GUI based tool, as you can see. This is a screenshot that I took. It parses the PE header, and you can skip to different types in the PE header as well, and look at what's in the header. And one of the things I like about this tool is that it does display things in a tree-like format, which is nice. Now here's another tool out here called pecheck.py because it's a Python script. This is a screenshot. I do like this tool as well because first of all, I can run this on Linux machines. I can run this on non-Windows machines because it is a Python tool. Here's a screenshot of the tool being run on the bottom. As I said, it is a Python script and it generates hashes of the exe sections. So if you want to actually hash different sections of a PE file, and you may want to hash different sections of a PE file because you want to check it or you want to fingerprint it for some reason. There can be multiple reasons for that. You may want to use PEcheck. Now, what PEcheck does is it does use a database. If you look at the command closely, it says pecheck.py, that's the script. -d is the database I'm going to use, and the database I'm using is userdb.txt. Userdb.txt is actually a well-known database, and I'm using that database against the malware.exe file. The userdb.txt file comes with another program called PEID. Those are signature files for this program called PEID. So if you download the tool PEID, you get the userdb.txt file. We will explore PEID as well in this throughout this course and another part of this course. I've used this tool. I've already brought this up. I showed you a screenshot of this tool before. Once again, here's another screenshot of this tool called CFF Explorer. It is a Windows GUI-based tool. It is a PE executable. The tool is a PE executable tool, but it also parses PE executables. So, of course, it's a PE executable because it's an executable. It's an EXE program. I can open up this program. You should know that by now. You should know what an executable is. It's an MZ program, but I can import other executables into this program, and then you can see I have this nice tree-like field where I can actually even edit the PE fields. I told you before it's a little difficult sometimes to edit some of the fields in the PE fields, but with this tool you can. It's actually very easy editing if you wanted to do that and manipulate the tools. A cool tool. Now I will tell you I saved the best for last. This is a Microsoft tool called PE Studio. PE Studio is one of my favorite tools. It lets you do a lot of examination of PE files, of executables. But the nice thing about PE Studio is that Microsoft has included suspicious behaviors that are in PE files. So they've looked at a lot of malware, and it's not all-encompassing. It is not by any means like a malware detection tool, but they do actually point out like, hey, you know what? These libraries are blacklisted. They shouldn't be used. These strings are blacklisted or outdated. And the reason they're blacklisted is because we see them a lot used primarily only in malware. So it actually highlights that for you in red. Like you can see imported libraries, 2 out of 6 were blacklisted, or imported symbols, 60 out of 109 were blacklisted on the bottom. And that's just once again, the terminology they use on what they're calling malicious behaviors within the program itself. But it is malicious behaviors. But it's a very slick tool. That's why I like it. It actually looks very cosmetically pleasing to my eyes. And it's just very easy to maneuver and manipulate different things. So there's no doubt if you are doing malware analysis, you will be looking at all of these tools. But especially if you are looking at PE files, you want to be at least looking at and be familiar with these tools, and then figure out which one works the best for you. All these I've talked about are open source or have some sort of open source or community version available free of charge. All right, thank you again. Hopefully you enjoyed this lesson. See you next time.